and welcome to Rocket Biologist, the show where we meet experts in medicine and biology. I'm your host, Dr. Adeel Nasir. My cosmic comrades, in this episode of Rocket Biologist, I present to you Dr. Ekaterina Kostioukhina, a medical doctor who graduated from the University of Miami Miller School of Medicine and completed her postgraduate studies at Harvard University. She has taught space medicine and crisis management at MIT, and in addition to her stellar academic achievement, she is a proud mother and an inspiring mentor. In this episode, she will guide us through the fascinating science of hibernation and how it could pave the way for long-duration human space travel. I hope you enjoy listening to this conversation. Hello and welcome to the show. We are talking to Dr. Ekaterina Kostioukhina. How are you doing today, doctor?
I'm good, and greetings from New Zealand.
Thank you, and bonjour from France. Without further ado, who is Dr. Ekaterina Kostioukhina?
That is a tricky question. It's more of a philosophical question that took a time to come up with. And I do ask myself that a lot. So, sometimes when they ask, just use a word or 3 words to define yourself. But what I find is that a person is multifaceted. And it is okay to do that. And constantly, despite my age and career and all that, I feel that constantly we are looking for that purpose in life. So who am I? Right now, I feel, I wear the hat of a doctor. Right now, I'm currently in the hospital and seeing patients, taking care of life. So I take that responsibility quite seriously. But I'm also a mother, and I highly appreciate that gift to be able to be a woman with all the challenges that comes with, but also the beauty of being responsible for the future of humanity. Also, I'm a wife, and I'm very grateful for having found that special partner with whom to share my life and goals and dreams and time. But also, at times I find that I enjoy wearing different hats. I enjoy being an explorer. I enjoy being a researcher, and different perspectives to try to see the world, to try to explore, to try to understand the different views of people. So I think it is an evolving question, and eventually with age, I'll be a grandma sometimes, you know what I mean, but it is an evolving answer.
Well, I'm sure that, even with the age and everything, your wisdom will grow further, and I believe that would be wonderful to see future you. Well, thank you for that. So, tell us about this metamorphosis from Ekaterina to Dr. Kostioukhina. How did this happen?
Well, it happened by asking the question of who I want to be. In medicine, I realized that life is finite, and youth is something that we have as a gift, but then eventually that time has its limitations. So it's important to figure out who you want to be. And society tells us that there are certain things that are preferred, but not everything that society tells us is something that is beneficial for us, for our personal gifts and talents. So I had to reinvent. I had to ask very sincerely of myself of whom I wanted to be, whom I will enjoy being, and when I am in my deathbed, like the patients that I have seen, who I would like to say that I was. So I decided that I really enjoy being somebody who helps society. So being a doctor certainly fulfills that role. And it certainly fulfills also a personal role, which is to learn forever. Yeah, medicine certainly does that. But then once that was achieved, I realized that medicine was not enough, that I still have that curiosity to continue learning, to continue contributing to complex puzzles, finding the answers to them. When I was a kid, I used to love puzzles, like the harder, the better. And as a grown up, my brain still asks for it. So science gives you that perfect opportunity. Also, as a kid, I wanted to be an astronaut, like many kids. And actually, I set on a journey. I looked up what are the requirements for it. And when I was a teenager, well, it said you have to study a lot, many years. So I went there, then forgot about my dream. But then eventually back in 2020, I saw on social media that NASA was hiring. So I looked at the requirements and I realized that after all these years, I have actually collected all the requisites for being an astronaut, and I applied. But during that time, it was also during COVID times, 2020. So we had a lot of introspection on our mortality and topics like that. During that time, I discovered space medicine. And it is in that field that where I felt home. I felt that space medicine is something that will allow me to study for forever, because there's so many answers so many questions that we need answers for. It also will satisfy my curiosity of something that is an extreme environment, that is an adventure, and well, it has the space component. And at the same time, it is something that I can, with my talents of science and being able to understand complex topics, I will be able, with my efforts, to contribute to those brave men and women who actually go to space. So I think I found my calling through that, by asking questions and actually listening to what my heart was telling me, whether it felt like home, whether it felt like something that I will enjoy doing, whether it like gave me that excitement in my voice, or whether it was just like a rejection. So it's important to be true to yourself and ask the questions to see where the answer will take you.
Well, that's a wonderful story. I would like that, people get inspired by that. So what about that scientific, sort of inspiration you had? Like, what inspired you to become a scientist? Like, if I see that, it came little after, during your career, that you were interested in space biology. But what thought that, what makes you think that, science is something you want to do? What's so special about it?
I think it happened since childhood. I was constantly attracted to scientific kind of activities. I did want to be a scientist when I went to school, and I remember even when, I had to work at a very young age, and I will take my breaks by going to read a physics book. And I will get reprimanded because everybody went to smoke and I went to read my physics book, and I was the one who got reprimanded of like, go back to work. So I was always intrinsically attracted to that. Then medicine came along, and more and more questions as far as aligning that intrinsic drive for science with something that I can actually put to use. So when I'm enjoying trying to figure out the puzzle of what is wrong with a person, I am helping them at the same time. So I think in retrospect, there was not a moment when I realized, I want to be a scientist. I was always attracted to science. Like, now that we have a son, I just see how many things come programmed into his behavior and the things that he prefers versus not. So I think each one of us has that inner calling for something special. Some people like dancing, other people like, leadership. I just enjoy scientific stuff, puzzles, and having my brain stimulated by understanding how the world works.
Did I miss something? You mentioned people were smoking and you were into science. You said that?
Yes.
Let's not promote anyone to smoke, but I can imagine that, that it's good that you chose the other thing. Wonderful. So, and as a child, I mean, if you recall that, who would be your scientific hero, or heroes if you had, or heroines? Please share that.
Yeah. Well, certainly I didn't learn about any heroines when I was a child, because when I was learning about the science, we did not have many. Now it is, thankfully, there are more role models. But I remember learning about Charles Darwin and reading his book, The Origin of Species, highly admiring how he put those observations together, how he went on this journey. And, during his journey, he noticed something. And then he put it together, and then he counted things, and he came up with an observation and an idea. So I highly admired that process. Also, when I started learning about genetics, which was really fascinating back in my time, James Watson, Francis Crick, now we learn that there are more women role models, but in those times, those were the ones that were more promoted. It was quite exciting when James Watson came for a conference at my university, having met that person from whom I learned in books and in videos. That was, it was like seeing Santa Claus for me.
Okay, that's well, I can imagine that. I think everyone who worked in the field of genetics, molecular biology, certainly was a hero for all of us. Wonderful. So I would now jump directly to your specialty, because you're a medical doctor.
Mm-hmm.
What brought you, to the field of hibernation and hibernation in space? But before that, I would like to start by asking simple question for the audience as well, that, they can follow what you are doing. And then I will go a bit, deeper in your area of expertise. So if I ask you, what is hibernation or torpor, how you call it, what it is?
Well, hibernation is what we hear about that bears do. They go to sleep in winter for a very long time, for months. And, before that, they eat a lot, they get fat, they go to sleep, and they do fine. That is how they weather winter. So that is an example of hibernation. But there are many other creatures, a lot of them mammals, who do hibernation. And right now we don't have a very defined definition for that, because it is still an area in progress. But what I like to explain it as is that it is a state of lower metabolism. Like, for example, during our normal day-to-day life, we can, we understand that increasing the metabolism many times it's good, because, it helps with burning fat and that kind of thing. That's where the majority of people see or hear about metabolism. But actually lowering your metabolism is quite a great strategy, an important strategy in the natural world. So from that strategy, what scientists have noticed is that even though the bears and the other creatures go into a state of not moving, not eating, breathing very little, into a state of very low metabolism, they emerge very healthy without the side effects that we see of something like that in humans. So just look at the bear. They gorge on fats, they become obese, and then they go to sleep, which is a lot of immobility. When humans do that, that is not good. We get heart disease, we get strokes, we get blood clots, we get pressure sores, the muscles atrophy. So there is a lot of fascination with the scientific world about why do these creatures, use that strategy to weather the challenging times when there's not enough resources, and why do they emerge so well? And there is an importance of that in the space field, because during space travel, we will be in an environment that is hostile to us. And it seems that hibernation, with the emerging research, is able to protect us from at least 4 of the 5 dangers that NASA identified in space, such as space radiation. It certainly does a good job at protecting when the other options are not as visible. The isolation and confinement problem, the psychological effects that it has on us, the altered gravity fields. Many astronauts will develop the muscle and bone problem. So that protects against that. And also the hostile and closed environments, because, you're decreasing the activity that the astronauts will be doing. So you're decreasing a lot of those dangers. So there's a significant interest in hibernation technology, just like the bears do it, or other creatures who hibernate, to put it to applications for when we humans go into an environment that is hostile to us.
Well, it certainly seems like that in the world of bears, we don't have problem with being fat. It's which is nowadays is a big problem for humanity. We talk a lot about that. So that's a wonderful thing. Well, I would like to have that feeling instead of getting this. I'm getting fat or something.
No,
okay,
you're right. Actually, one of my specialties is obesity medicine, which I pursued precisely because that is one of the major problems that humanity is experiencing that is affecting our health. And it's a growing problem despite all the interventions that we do. And actually, hibernation technology, especially from bears, one of the benefits of doing that research is that it teaches us about the metabolism that happens in bears, so we can apply it for obesity, for understanding obesity and addressing that. So that is a great point.
Okay, thank you. So basically, the evolutionary advantage of hibernation in animals. What's your thoughts about that? And then I will ask a connecting question after this, because I think I'm trying to understand that before we go to, out of this world. So let's try. So what is the advantage you think they have, evolutionary advantage?
That is a question that scientists have asked themselves, because it is a quite prevalent activity. It's quite a prevalent strategies across many species that is being used. And basically, what they do is they just go out and be quiet and spend times, instead of looking for food, instead of being active, instead of reproducing, they go and just be quiet. So when they are sleeping, they're not moving, they're not alert. So one of the concerns is if when you are sleeping and somebody finds you, you can be eaten. Or you may not be aware of what's going on in your environment. So that is quite a danger. But it seems that going into a state of low metabolism is useful for conserving energy. Our energy comes from the environment. So we humans are having better times during modern times. So that's why it's somewhat difficult to understand. And most of the times we're trying to go on diets to not gain weight, to increase our metabolism, to burn all the yummy things that we eat. But before, and also in nature, energetic resources are limited. So there is a strategy, there is the importance of going into a quiet time when the conditions are not favorable. Mostly it is during winter times when vegetation is less available, when there's cold, and cold protection is not easy because that requires burning energy. But also other creatures go into a state that is of low metabolism in hot areas, or just simply when food is not available or when there is not enough water. So basically we see strategies across many different species when the conditions are not favorable for their particular tools. They go into a state of dormancy to weather the times. It's that patience that they do in order to survive and wait for better times.
Well, so it certainly seems that cold weather or winter has something to do with it. I don't want to repeat that famous sentence from this TV series, Winter is Coming. So winter kind of connect, how does that, it activates some kind of molecular mechanism in bears or something at cellular level they go. So that would be, I would like to know what do you think about it? And then going directly to, this, your space hibernation program.
Yeah, that is a question that I would like to know, and the entire hibernation community would like to know, and it is being actively studied. What we do know is that it is a combination of the stimulus of the environment, so the conditions of either cold or lack of food, or some conditions that are perceived by the organism as something that is hostile. But also there is a mechanism inside of our brain that is called a circannual rhythm, because many hibernators have been shown to go into hibernation state even when the food is plenty and the temperature is fine. So it's a combination of both. Just like we have heard about circadian rhythms, which is the rhythm that we follow every 24 hours or so with the sun. Also, the annual rhythm of the sun of the Earth going around the sun and creating the seasons, depending on which hemisphere and which latitude we're in, but still there are changes in seasons. So how that affects us is part of our biology, is that combination. We know that it is in our brain, the activation happens in our brain through the senses and through the programmed genetic pathways that we have. So the exciting hypothesis is that because there are many mammals who hibernate, and even a primate, we likely have some of those shared genetic pathways that might be dormant. And some things that we do see in humans is sleep. We actually lower our metabolism every single day when we sleep.
So what you are suggesting that if I keep sleeping for 48 hours, I can lose my weight? What's going on here?
Indeed. Well, because you're not eating and energy consumption happens. So yes, and one of the reasons why hibernators wake up is because they reach a specific weight. So they need to go and search for food. So that is
I should work on that idea to earn some money. Sleep, people, if you want to get fit. Okay, well, that's wonderful. So it clearly seems that what you told us that that lower temperature or winter does has effect, but it's mostly happening in brain of those. Mammals who are actually going to the space hibernation. Sorry, the hibernation itself. So, keeping that in account, if you're trying to mimic that situation or for something that is not hibernating, do you need cold temperature, or you can play with some, you can alter the brain chemistry and bring them to the hibernation state? But is that even possible?
Yes, that's a very good question. But before moving on, I have that responsibility as a doctor. Before, we give medical advice on losing weight. Well, actually, sleep does help with weight, because if sleep is disturbed, then there is a propensity for gaining weight because of the stress that it produces. So healthy sleep habits certainly help. And then also when you are sleeping, you are not eating. So So yes, from one perspective, in order to have a balanced weight, it's important to have a healthy sleep habits for us humans. And then going back to that question, now that I feel that I have done my duty, disclaimer.
Well, there was nothing wrong on your side. I was the one who was thinking.
No, but it's important to clarify, because it's sometimes we come to conclusions, but each one of us has different perspective of seeing the world, of seeing a concept. So it is important to bounce back those ideas to make sure that we get them right. So going back to the concept of cold, yes, you can induce a state of low metabolism by subjecting an organism to cold. And in fact, it is something that has been used for lots of cases in the medical field for many years. It is called cold therapy or targeted temperature management, and it is used in conditions when a person has lost its circulation in order to avoid damage to the brain and other organs. Complicated stuff. But the whole point is that under certain conditions, we put people to cold temperature in order to help protect them. Targeted temperature management. For a good number of years, it was thought with good evidence at that time that it protects people. Fortunately, scientific evidence emerged with bigger trials that it actually is not very helpful. Why is it not very helpful? Because what we see in natural hibernators is that they do lower their temperature. So, for example, squirrels who hibernate, they can reach a temperature of 0 centigrade. Like, it's fascinating, like almost freezing point. Their ambient temperature. So they quite significantly decrease their body temperature. So also some cases of humans that were found that had accidents, like for example, fell into a freezing lake or in an avalanche, they were rewarmed after hours and they survived just fine with no side effects. And some stories in Roman times about soldiers having better outcomes when they were farther away from the fire. So we had observations, and not just that. So the kids will know this, and the moms will do that. So what happens when you hit your head? What do you do?
You ask why what I did wrong to get into that trouble? I don't know.
So what will mom do? Well, I don't know. Maybe it has to do with cultures, but one of the strategies that the moms will do is put something cold on it, like the frozen steak or something from the freezer, and put it there, right?
Yep.
To prevent that swelling from happening. So even even the doctor moms, they for like all that folk knowledge about cold temperature and decreasing swelling, decreasing inflammation has been passed on from generation to generation. So cold therapy certainly helps for certain conditions. The problem is that it can be better. So now that we have more information on what happens, how the natural hibernators do it, we can do better. And the point that we're realizing is that temperature lowers afterwards. First, there are some changes that start in the brain. There are adjustments. There are some cascades. There are hormones. There are different strategies that are used with the neurological system. So the body is prepared through either days, weeks, or sometimes hours. So it depends, but it takes time, and it starts in the brain, and it has to do with our intrinsic chemicals. And then, by the way, when the metabolism lowers, then temperature lowers. So now that is what we're trying to do, to find those triggers like you were asking in the higher cascade, because when you try to induce cold, even in natural hibernators, it's very stressful to them. They don't like it either. And that is what we're noticing of one of the drawbacks of cold therapy, of hypothermia protocol or targeted temperature management, is that it induces the stress. So being in the cold is fine, but first you have to go through that shock to the body of lowering that temperature. So to lower that temperature, inducing cold from outside is not, it's not the best way to do it, but it has been practiced quite a lot. It's just that we're advancing our knowledge.
Well, sounds like a wonderful insight. So now directly jumping on this space hibernation. Mm-hmm. So what is going on that front, and how you are contributing to that subject? So what's your project that actually would you like to share that, what you're doing?
Yeah, well, the project is called Hiberia, mm-hmm. and the goal is to advance the science and research of hibernation and inducing hypometabolic states. Why? Because there are applications for space travel. Right now, as we have it with the tools that we have, we will not survive a long trip to Mars. Those months in exposed to radiation and the other dangers of space, we're not likely to survive it well. It's quite a challenge. But hibernation, putting a person, the biological machinery, the human, into that state helps protect from so many of those challenges. So it is actually a good solution that if we get it right, we will be able to advance space travel. But not just for space travel, because it is something that it is important, but we have a lot of troubles on Earth too. It's fascinating. The more I delve into this research, the more I realize that it has lots of applications for life on Earth. Like, for example, in trauma care, for when we have significant blood loss or significant shock, decreasing the metabolic rate until help arrives or until you get into the proper setting. It actually helps people to survive until we can combine it with other technological advances in medicine to repair the body. There are applications for metabolism, for understanding these obesity troubles that we have, diabetes, chronic kidney disease, frailty, aging, osteoporosis. That way when, the majority of troubles that grandmas have, elderly females, is that we get osteoporosis and with minimal injury and sometimes even spontaneous, they can fracture their hip, and that can be a terminal event. So it helps a lot, and from that perspective. Also, decrease in muscle mass. Frailty is one of the major causes right now that we conquered many diseases with antibiotics and the other marvels. So frailty is at the forefront of the troubles in medicine that we're suffering with, that is costing a lot of suffering, disability, and cost to society. There is I can keep going with the applications, but the point is that it's important for space travel, and it's also important to life on Earth. So it is a research that is not just, when I started, I saw it as science fiction, something cool, right? That's why I got into it. It was like a challenge, something curious, a puzzle to understand. But now I realize that it is important.
Which science fiction movie was very, you find that it's closer to real stuff? Like, which one is? So which was your inspiration to start that?
I realized that the majority of space movies, they have a form of hibernation included. Why? Because it solves all a good percentage of the problems that we're experiencing in space. Even I remember traveling from China. There was a space movie, and the different cultures, they do think differently. The emphasis was on something else, so there was interesting to see that cultural differences. But guess what? They also had hibernation in it. So it is.
That's the common theme everywhere.
Yes. Yeah.
Okay. All right. So, talking about that space hibernation and advancement in space hibernation, so you would do it by making some device, if I'm correct. How that device would look like, and how far along are you in that research?
Well, I'm not exactly doing a device, but from what I've learned in the research is that devices are certainly going to be important because it's not about just one intervention, it's about a combination of things. And we certainly, as humans, we depend on the tools that we build. Just like we have shelters, we have computers, we have phones, we have the stick to reach the higher fruit. We depend on those tools. So in order to advance this complicated topic, we need different kinds of tools. So one of my strengths as a scientist is, and again, I think this is important also for people to realize who are trying to get into science, is that I'm not enjoying being at the bench and doing experiments. When I was in university, I did a summer of that, and I really disliked it because it was a lot of work to answer a very small piece of the puzzle. My strength is collecting that global worldview, that global information, those pieces of the puzzles that other researchers and scientists so diligently collected, not just in the present, but also in the distant past and across the different cultures and languages and geographical borders and multidisciplinary subjects, and put it all together in order to understand, in order to answer the question, how can we induce a state of lower metabolism in humans? So my project is to create a platform that will bring all the scientists, because I thought it was something, again, that was being studied as a hobby, but I realized that there are many scientists across the globe for many years, since at least the 50s, studying it for space exploration, and the 1800s studying it for understanding the animal hibernators. So it is a important research that is happening, but it is too scattered. So my goal is to do something that we learned with COVID. When COVID happened, we thought the vaccine is going to take minimum 18 months. That's what we were being told. And it took much less. Why? Because there was collaboration. Humans united for a common cause. They saw that it was important. They were given the tools of communication, collaboration, and ability to make that happen, and that urgency, and something so beautiful happened. So my goal is to recreate that, to bring that community of scientists together so that they can share those ideas, not needing to replicate one thing or another, or get the answers to their questions from people from in other languages, in other parts, in other disciplines, and then advance that together. So that requires a collaboration platform. And part of it is also having an easy to understand source of knowledge that they can refer to, or that their research assistants who are just starting can go to, which will be in the form of a textbook, because, that is something we're familiar with. And the science, neurosciences of learning tells us that it is one way that we can put that knowledge into our brains. Because at the end of the day, even though we're having artificial intelligence and you can just type things in and it gives you amazing answers, we still rely on the biological intelligence. And the biological intelligence is requires to put that data through the senses, through repetition, which is the mother of all learning, into the brain. That way our brain can process it, and then we can come up with the answer, come up with studies, with research, and also the collaboration to bounce back those ideas. So it is about educating those researchers by giving them the up-to-date, easy to digest, easy language that they can refer to, by collecting all the research that is available and programming now the artificial intelligence with a chatbot, which will be the modern way of acquiring knowledge. So imagine, there are some examples that are fascinating, but the goal is to get all of those articles which there are at least 5,000 roughly, plus everything that is peripherally, program them into the chatbot so it is used as the data, and make it available for the scientists who are into this field to interact with it and ask the questions. What kind of questions? Very important. Has states of hypometabolism been induced in humans? Until last year, the answer was not. And now it is. Now we know that it is, but it is not well known because it is a state not of hibernation, not of torpor, but a state of shallow torpor. So it is steps towards that. Then you can ask other important questions. Who are the major researchers in the US, in China, in South America, in Russia, in Europe? That way you can connect with them. So you can build together that community, and you can get those answers in seconds once you have it programmed properly. Instead of you may not even ask that questions because it's an obstacle. So that is the main thing. And the other last ingredient is to make it open science. That way it is accessible across geographic barriers, across languages, and across professions. So those three pillars.
Well, that's wonderful. So I'm right to assume that what you are suggesting, that if we want to be an intergalactic species, we need to start by becoming intercontinental species.
Wow, that is beautiful and very insightful indeed. Yes, so we need to collaborate. Just like I always think that there's the importance of the sum is greater. No, the whole is greater than the sum of its parts. And I think about the unicellular organisms and how much they are alive and they're able to do things. But when the cells come together, we're able to have consciousness and curiosity and this beautiful emergent property. So you're right. In order to become a society that's not just limited to the terrestrial domain or the other domains that we were able to expand to, but also to the space environment, we need to overcome those barriers and become more connected. That is beautiful. I'm going to quote you on that.
Thank you very much. My cosmic comrades, we will continue our intergalactic conversation in the next episode. Until then, stay curious and stay connected as we are just beginning our odyssey into the heart of the universe.